Welcome. This is video number 331. In this video, I am going to explain the theory of GARCH and GARCH model, and I will also interpret the results of the estimation of these models. Let me start with the introduction. GARCH stands for Autoregressive Conditional Heteroscedasticity, where GARCH stands for Generalized Autoregressive Conditional Heteroscedasticity. GARCH models were initially introduced by Engel in his famous paper in 1982, and the GARCH models were introduced by Bullersleff in 1996 and Taylor in 1986, famous book. So later on I will share with you the complete references of these three studies. These models are widely used in various branches of econometrics, specifically in financial time series analysis. For more details, you can see these references. Autoregressive conditional heteroscedasticity models are specifically designed to model and forecast conditional variances. The variance of the dependent variable is modeled as a function of the past values of the dependent variable and independent or exogenous variables. This is the complete reference for Engel 1982, and this is the complete reference for Bullersleff 1986, and finally this is Taylor 1986 complete reference, and the title of this book is Modeling Financial Time Series, and the book was published in New York by John Ville and Sons. In order to develop an autoregressive conditional heteroscedasticity model, we will have to provide three distinct specifications: one for the conditional mean equation, one for the conditional variance, and one for the conditional error distribution. So we may begin by describing some basic specification of these terms. So let us start with the GARCH 1-1 model, and we begin with the simplest GARCH 1-1 specification, and it is given by equation number 1. The mean equation is given by that is, the conditional mean equation is given by equation number 1, and the conditional variance equation is given by this equation number 2. The mean equation given as equation 1 above is written as a function of exogenous variables vis-a-vis an error term. Since sigma square t is the one period ahead forecast variance which is based on the past information, it is known as the conditional variance, and the conditional variance equation specified in equation 2 here is a function of three terms, that is, a constant term, 2, news about volatility from the previous period which is measured as the lag of the squared residual from the mean equation, that is epsilon square t minus 1, that is the ARCH term, and then we have the GARCH term which is the last period's forecast variance sigma square t minus 1. The 1-1 in the GARCH 1-1 model refers to the presence of the first order autoregressive GARCH term, the first term in the parentheses, that is this one, and a first order moving average ARCH term which is the second term in parentheses. An ordinary ARCH model is a special case of a GARCH specification in which there are no lagged forecast variances in the conditional variance equation, that is a GARCH 0-1. So that is the ordinary ARCH model, and which is a special case of the GARCH specification in which there is no lagged forecast variance in the conditional variance equation. This specification is often interpreted in a financial context where an agent or trader predicts this period's variance by forming a weighted average of a long-term average. The forecasted variance from the last period, that is the GARCH term, and information about volatility observed in the previous period, and that is the ARCH term. If the asset return was unexpectedly large in either the upward or the downward direction, then the trader will increase the estimate of the variance for the next period. This model is also consistent with the volatility clustering often seen in financial returns data, where large changes in returns are likely to be followed by further large changes. Then we discuss the GARCH QP model, and that is higher order GARCH model denoted by GARCH QP, which could be estimated by choosing either Q or P greater than 1, where Q is the order of autoregressive GARCH terms and P is the order of the moving average R terms. And the representation of the GARCH QP variance is as follows. And here is the way how to estimate an arch or GARCH model. So we will open the equation specification dialog by selecting quick estimate equation, by selecting object, new object, and then equation. Then we will select arch from the method drop down menu at the bottom of the dialog. Alternatively, we can also do so by typing the keyword arch in the command line. Both creates the object and sets the estimation method. The dialog will change to show you the arch specification dialog, and you will need to specify both the mean and the variance specification, the error distribution, and the estimation sample. So this is a way how you do this. So model is GARCH or TARCH, and here ARCH1 and GARCH1. So this is the simplest representation, and here is the dependent variable, that is the difference of the log of SPX. This SPX is a dependent variable and C is the intercept. In the dependent variable edit box, we should enter the specification of the mean equation, which I just referred to. Then we can enter the specification in the list form by listing the dependent variable followed by the regressors. We may also add C to our specification if we wish to include a constant term. If we have a more complex mean specification, we can enter our mean equation using an explicit expression. If our specification includes an arch M term, we should select the appropriate item of the drop down menu in the upper right hand side of the dialog, and we may choose to include the standard deviation, variance, or the log of variance in the mean equation. Here is an example in which we fit a GARCH 1-1 model to the first difference of log daily S&P 500, and that is given by this specification D log SPX, and the work file that we use is the stocks WF1. Using backcast value for the initial variances and computing Bolotz-Leff Wooldridge standard errors. The output is represented below, and here we can see this is the estimated output. So the method is ML arch and normal distribution, and here is the specification of the model, and this is the backcast parameter, which is equal to 0.7, and this is the variable constant. This is the coefficient, standard error, z statistic, and probability value, and this is the variance equation. And here in this lower panel we see various other statistics, that is R squared, adjusted R square, standard error of regression, the Durbin-Watson, and so on. And now we will interpret these results. By default, the estimation output header describes the estimation sample and the method used for computing the coefficient, standard errors, and the initial variance terms and the variance equation. And we may note that the method for computing the pre-sample variance, in this case backcasting with smoothing parameter lambda is equal to 0.7, that we observed in the earlier slide. The mean output from arch estimation is divided into two sections. The upper portion provides the standard output for the mean equation, while the lower part, labeled various equation, contains the coefficients, standard errors, z statistics, and p values for the coefficients of the variance equation that we just observed in the previous slide. The ARCH parameters correspond to alpha and the GARCH parameters to beta in equation 2 that we discussed earlier. The bottom panel of the output represents the standard set of regression statistics using the residuals from the mean equation. You may note that measures such as R squared may not be meaningful if there are no regressors in the mean equation. So here, for example, the R square is negative, which is not meaningful, because here we didn't use any regressor. There was only constant. In this example, the sum of the arch and the GARCH coefficient, that is alpha and beta, and that is very close to identity, which indicates that volatility stocks are quite persistent. This result is often observed in highly frequency financial data. Thank you for your attention. Ladies and gentlemen, if you haven't yet subscribed to this channel, kindly do subscribe the channel, and do not forget to click on the bell icon so that you can get timely notification. Kindly share this video and channel with other friends and colleagues so that they may also get benefit. Other people may